Right, we have completed a major portion yesterday. Friction we have started and almost we are towards the end of it. Write it all of you, write down the question, let me know. This text done, then I'll discuss. Yes, class. So see, here it says that a body of 10 kg is placed on a surface having coefficient of kinetic friction and static friction. So see both the values of the coefficient of kinetic and static friction, these are given. Now you have to calculate the maximum static and kinetic friction. So see class, in such types of question, first we have to draw the FBD. I have told you, whenever you have any type of these questions, you have to draw the FBD. So free body diagram, if you have a body of mass 10 kg, there's this body of mass 10 kg. So normal reaction above, mg below, and see frictional force will be acting in the opposite direction. Now, coefficient of kinetic friction is 0.2, static friction is 0.3. So see here in this case, N is equal to mg, which is equal to 10 into 10 equal to 100 Newton, because this is a force itself. Now, frictional force, static friction I am calculating. So it is coefficient of static friction into N. This is 0.2 into 100. No, static friction is 0.3 now. So this is equal to 30 Newton. Now, when we are calculating kinetic friction, so kinetic friction is equal to mu k into N. So this is 0.2 into 100, which is equal to 20 Newton. All right. Shaima hasn't joined today. Jobita, Jesleen, Sabiha, Zainab. Sabiha, your internet is working now. Are you able to hear? Sabiha, just respond if you can. Jesleen, Zainab, you also open the camera. It is better, Sabiha. Okay. Will you be able to? You're still in the village. Okay then. Okay then. Let me know if the internet goes. See, Sabiha, you can do the best thing which you did in the last class, that you've texted on WhatsApp. So that helped me to get about you. All right. So very good, Jobita. Zainab and Jesleen, please, both of you also. So this is kinetic friction. Fine. So we have static friction, we have kinetic friction. All right. So this was our first part. Yes, Abhiya. Initially, I couldn't understand, but then I received your message. Then I understood that because of the network issues you're having. Let's see till how many days you're here. For, I think, till the time you're having your vacations. Second portion says if applied force is 10 Newton, then we have to find out the static friction. Now see, applied force in class, this part, no, you don't even need to solve here. If the applied force, this is 10 Newton. If I'm pushing this and this is 10 Newton, and I have to calculate the static friction. Static friction is self-adjusting. This is the property which we studied in the last class. So if it is self-adjusting, it will directly become whatever is the applied force. So here, if the static friction, if the applied force is 10 Newton, this will also become 10. So second part, see why? If this is the body, 10 kg applied force here, this is 10 Newton. So backwards behind it, the static friction will be the same. So static friction will also be 10 Newton. Fine. Third part, if applied force is 50 Newton, you have to decide whether the body will accelerate or not. And if it will accelerate, then you have to tell the acceleration. C class, in such cases, whenever you have the applied force and you have to decide whether the body will accelerate or not, in such cases, what you have to do? Firstly, you should know what is your static friction. Then only you will be able to figure it out whether you have your static friction or you have your kinetic friction available. Why? Because we have studied that static friction, whenever we have static friction in our calculations, if we overcome it, then only we'll be able to analyze things. Now here, look, this is a body of mass 10 kgs. Here the force applied is 50 Newton. Now what is the static friction? We have calculated in the first part. Remember the static friction, 30 Newton. It means behind 30 Newton will be acting, right? Now the applied force here is greater than the frictional force. Applied force here is greater than the static friction. So applied force is 50 Newton. Backwards it is 30 Newton. It means the body will definitely accelerate and move towards the body having greater force, right? And you already know that net force is always equal to mass into acceleration. What is the net force here? Applied force minus frictional force is equal to mp. This is your equation. You have to find out acceleration. Using this, you can calculate. See, when you substitute here, it will be 50 minus 30 is equal to 10 into acceleration. This is 20 is equal to 10a. Acceleration is equal to 2 meter per second square. Understood? See what we have done. We've actually calculated the net force. What is the net force? Net force is mass. Net force is equal to mass into acceleration. But what is this net force? 50 minus 30, right? And how can you ever predict whether a body will be having static friction or kinetic friction? By actually calculating them. Calculate and check it with the applied force. If you see both are equal, then the body will not. If one is greater, it will. And if it is moving, it is kinetic friction. If it is not moving, that is your static friction. Write it down, class. One thing here, class, in the last part, see, I have told you that this is static friction. But class, when we'll be calculating, now we know that this friction is greater than the applied force. This is the applied force. This is greater than the static friction, right? So it means the body will move. If the body moves, then the friction that is acting is kinetic. So instead, we'll put here, we'll use the value of kinetic friction. So it will be 3 meter per second. Because this value, this is of the static friction. But once the motion has begun and we are calculating acceleration, so we'll have kinetic friction. Class, tell me, is it clear to all of you? Yes. Okay. Write it. Okay. Good. Write it. Any doubts, please let me know. Mhm.
Ma'am, can you scroll down?
Second one, see, second one we have to find out the static friction. Now, static friction is when the body is not moving. So what we've studied, static friction is a self-adjusting friction, right? So whatever is the applied force, the static friction becomes equal to it. So here also in this case here, as soon as the value of the static applied force increases, static friction increases. But here the applied force was, I think, 30 or some 50, 10 Newton. So static friction will also be 10 Newton. That's why here in the third part, since this has begun the motion, it is in motion, I cannot consider the static friction. I have to use the kinetic friction. That's why I have changed this, that 50 minus 20, not 30. Look in the next part. Here we have the angle of friction. Now, understanding of angle of friction is very important. What is angle of friction? Because you have two quantities over here, angle of friction and angle of repose. So you should be aware about this. What is angle of friction and what is angle of repose? So what is the angle of friction? Basically, you know now the normal reaction. It is a perpendicular force, fine, perpendicular away from the surface of the body. Downwards, mg will be acting, right? Now see, applied force is acting over the right hand side, and on the opposite side, the frictional force will be acting. Now class, here when you have this applied force, you have the frictional force. Normal reaction and the frictional force, both are making an angle of 90 degrees, right? Or both are vectors. Normal reaction is also a force and the frictional force is also a force. So if two vectors are present which are representing the adjacent sides of parallelogram, so the resultant is given by joining the diagonal. Suppose if I have this parallelogram with me, the diagonal will be this. This will be the resultant. So it is the resultant of normal reaction and the frictional force, right? It is this resultant I'm talking, this R. This is the resultant between the normal reaction and the frictional force. Now, what is the angle of friction? Because again, I'm telling, be aware whenever the angle portion is asked, whether it's angle of friction asked to you or it's angle of repose asked. This is angle of friction. So angle of friction is basically the angle between the normal reaction and the resultant of normal reaction and friction. This is the angle of friction. And what is its formula? Very simple, very easy formula. See, this is P, this is Q, this is O. In this triangle, if I take tan theta, if I take tan theta, this will be equal to QP divided by OP, right? QP divided by OP. So here this will be equal to QP divided by OP. What is QP? Look, QP, this is parallel to the frictional force. So QP can be written as frictional force. And what is OP? OP is the normal reaction. So F divided by N. Now class, what is the formula of the frictional force? Law of friction. What was the law of friction? That frictional force is directly proportional to the normal reaction. So F is equal to mu N. This is the formula of frictional force divided by N. N and got cancelled. Your mu is equal to tan theta. This is very important. This is. So what is the angle of friction? It is the angle which the normal reaction makes with the resultant of normal reaction and friction. Resultant of normal reaction and friction is this. Normal reaction is this. The angle which they are subtending here is this. Write about it. Look now, what is angle of repose? See, when the body just begins to move, when the body is just sliding down and it just begins to move, that minimum angle which is formed, it is called as angle of repose or angle of sliding. All right. So what is angle of repose or sliding? Minimum angle of inclination at which body just slides down. All right. See, if we resolve this, mg is here, this is theta. So see, this angle here will also be theta. So mg here with this, so it becomes mg cos theta. Right, class? See, mg, gravitational force will come downwards. It will be acting downwards. Look here. This is the body. This is the gravitational force acting down. Normal reaction is perpendicular to the surface because it is an inclined plane. So it is perpendicular to the surface and away from the body. Now in this case, since the body is inclined to some theta angle, look here. Here, this mg is acting downward. So you have mg cos theta. Why? Because this is theta. Look, this is 90 degree, right? So it will be 90 minus theta. This total is 90 degree. So again, this part will become 90. This will become theta. Understood? See, this is 90 degree. This is theta. So total it becomes 90 minus theta. This total is 90 degree. So this angle becomes theta. So this is theta. So when you resolve the vectors, it's like mg here with theta here. So this will be, and this will be, two components will be there. So this becomes mg cos theta and the perpendicular one will become mg sin theta. Mg cos theta and mg sin theta. Understood? So this is how you have to resolve these two vectors. So mg cos theta, mg sin theta. Now see, frictional force is mu n. What is your normal reaction equal to now? Normal reaction is equal to mg cos theta. Look, n is equal to mg cos theta. Frictional force is equal to mg sin theta. You have these two equations with you, 1 and 2. So why have we resolved these two? Because we always want along the plane or perpendicular to the plane. This is how you have to solve, along the plane or perpendicular to the plane. Now let's just put the values in here. As in, let's divide these two. So f by n. This is mg sin theta divided by mg cos theta. mg got cancelled. Again, f by n. This is equal to mu n. See, same answer we are getting here also. Same formula. Mu n by n. Sin theta by cos theta is equal to tan theta. So mu is equal to tan theta here also. So values are same here as well, right? We'll see some questions on this, so it will be clear. Write down this
Ma'am, can you scroll up? Ma'am, can you scroll up for a minute? Okay, ma'am.
Okay, see, value, first answer Zainab has given 4 by 5. Shaima, 4 by 5. Cos 37 is 4 by 5. See here, when we'll be solving it, this will be having the value 10g, right? So this becomes 10g cos 37 and perpendicular to it, this one. This will be 10g sine 37, right? So, and perpendicular, we have the normal reaction. Away from it, we have the friction force. So this is the FBD. We have drawn the free body diagram, all the forces which are acting. Now, in the first part, the normal reaction is equal to mg cos 37 degree, right? So normal reaction, mass is 10, g is 10. This is 4 by 5. So this is equal to 80 Newton. Normal reaction 78.4. So this is using 9.8, Shaima?
Yes, ma'am.
Yes, so exact correct answer. Because this I have been taking nothing and there it wasn't mentioned anywhere to take it as 10. So correct answer, Shaima. Coefficient of friction is 0.3. So we have to tell the. Acha, one more thing, class, regarding that I'll tell you the values. But first, let me tell you this. Frictional force is mu n. So this is equal to 0.3. And normal reaction is 80. So this is equal to 24 Newton. Now, class, one thing. Have these values remembered because in your chapter, especially in the inclined plane problems, I have seen this coming. Remember one, see cos 37 degree is 4 by 5. Fine. So cos 53 degree will be 3 by 5. These two values are often asked in the inclined plane problems. Then you have sine 37. So it will be, this is 4 by 5. So this will be 3 by 5. And sine 53. If this is 3 by 5, it will be 4 by 5. So remember these values, just learn them. Make a note point and learn these values. Because see, most of the questions of inclined plane I have seen where these values cos 37 and sine 53 and cos 53 and sine 53, these values are used. Write it. Yes, Jovita, I'm ending the class. I have heard about this. I think you've informed the team, so I'm ending the class after this. This completes the friction topic also. Now we are left with circular motion only. Though circular motion is a part of work, energy, and power, but we'll complete it here because most of the portions are related to it. So we'll complete it here. So work, energy, and power will be very less for us to deal with. This text done. When you all have completed, I'll end the class. Okay.